Hi Cam 1212. Let's do a little base equilibrium problem, and we'll do a little solution here, and we'll go from there. All right, so zuccheramine is a weak base. You can see that because you're told, number one, that it's a weak base. Also, it's got this nitrogen in there with 3 things bonded to it. That's a perfect sign that this thing's a base. Plus, it's called an amine. All of those are indicators that you're dealing with a base. So keep that in mind when you're trying to choose what exactly you have in your solution. All right, so we've got a Kb, we're given that nice value, and then we're told we've got a container with 350 milliliters of a particular solution. What's important here is that we know what the concentration is, so we don't have to compute it. So don't go looking to try to use this for anything right now. It's not important at this phase because it's just telling you how much of this stuff we have. So to write this out, we need to first write the equilibrium, and it's a base, so it's going to be the amine with the water acting like an acid, the amine acting like a base. So this is going to accept a proton. This proton will come right on over, and that's what we're going to see. All right, we're going to form then ZH2NH plus and OH minus. The base should produce for you an OH minus. So then we can start filling in what do we know for our ice table. Well, the first thing we put in is our initial. There's 0.4 of the base. We don't really care about the water because it's a liquid. And then 0 of the other stuff. At this point we need to calculate Q. So Q is equal to 0, which means it's definitely going to shift to the right. It has no really other option. Plus Q is equal to 0. 0 is less than 5.38 times 10 to the minus 8, so it'll shift to the right. So if we shift to the right, we fill in our ice table with the change row, and then we add those two up and we get a nice column of, or a nice row with our equilibrium values. Once again, if you take a good look, this X right here and this X right here are the concentrations of these species at equilibrium. So if we can find X, we can find the concentration of the hydroxide, and that means we can find the POH with pretty much relative ease. So how we go about doing that is we write the equilibrium expression as normal, and then we plug in the equilibrium values, which we get once again from this equilibrium row right here that we've built the ice table to find. When we get here at the end of the calculation, we see that there's 0.4 minus X, and that we approximate that as just 0.4. X is going to be a very small number. 10 to the minus 8 means that most of it stays as the base and very little of it breaks down, so that means X is going to be extraordinarily small. When we compare something that's extraordinarily small to 0.4, we can ignore it. It's essentially like Bill Gates walking down the street and a nickel falls out of his pocket. I think he can ignore that. It's not going to be a big deal. Matter of fact, he could probably drop 500 bucks. Wouldn't worry. You and I, we might go crazy over 500 bucks, but not someone like Bill Gates. $500 is just nothing. It's like a nickel to you and me, or a penny to you and me. All right, so now that we've made that approximation, we can just multiply this 0.4, the 0.4 right here, we can multiply that on both sides, so we end up with X squared times 0.4 times the 5.38 times 10 to the minus 8, and we get this lovely little answer. Take the square root, and we notice that that square root is going to give us X, and X is equal to OH minus concentration, so we get 1.47 times 10 to the minus 4th molar. There should be an M there. And to finish this bad boy off, we see that the POH is equal to the minus log of that X, and that's 3.833, and the pH is 14 minus that. So not too hard of a problem to do. You just have to identify it as a base and know that you're going to end up with the OH minus, which gives you this last step right here that you have to do. All right, so there you have it. That is a base equilibrium problem, and I hope this helps you understand acid-base equilibrium a little better.